In this session we are going to learn what algorithms are. I hope many of you know what an algorithm is, but we'll just have a quick revision of what an algorithm is now. As previously stated, algorithm is a step-by-step procedure to solve a simple task. Suppose, now what is the problem? What are the problems I could have? Suppose if I have a problem in making tea or preparing tea. Now that is a problem for me. Now if you give me the recipe of tea, that is how to put a vessel on the stove, how to pour the milk, and what are the key ingredients of preparing it, and if you say each and every step for me in a proper manner, that is the solution you have given for me for my problem. So that is what we treat as algorithm in computer language. Now to be more specific about the definition, algorithm can be stated as the step-by-step procedure to solve a given task. Now every algorithm must have some properties, so that it has to be stated as an algorithm. Why? Because if anyone can say how we can prepare a tea, but it cannot be called an algorithm. Why? Because everyone may not be clear about their recipe. So now we'll see what happens with the algorithm and what are the properties it must hold. Coming to the first property, it is input. Now every algorithm may not have any input, and it can have more than one input also. That what do we mean is, we may not have any inputs and we can have inputs also. It can be clearly stated that it can have 0 or more inputs. Now what about output? Now output, after the entire algorithm is traced, we must have at least one output and more than one output for that algorithm, for us to understand that the algorithm has worked for us. Next, finiteness. What do you mean by finiteness? In the word itself we have finite. So it must be countable. So you have to state the solution in countable number of steps. You should not give your recipe in 1000 lines or 10,000 lines for just a tea preparation. That will not be called a solution for my problem. It must be in very less number of steps. Next, definiteness means it must be very clear. There should not be any confusion in saying your solution. Suppose in the tea preparation itself, if you say that directly pour milk, where do we pour the milk? We have to pour it in a vessel, and before that the vessel has to be placed on the stove, and the stove must be lit. So everything will be happening in a sequence. That sequence must be stated clearly. Next, we have effectiveness. What do you mean by effectiveness? After we write a algorithm, it must be easily converted into a program statement. Suppose I am adding two numbers. What is the concept of adding two numbers? I should have a number A, I should have a number B, and I should be able to add them and store the result in another variable C. I have to print that C. So now when I write this algorithm, I must be able to convert it into a program. Either it is a C, C++, Java program, anything it is, it must be convertible into a program statement or a program. So these are the 5 properties, and an algorithm must hold all these 5 properties.